Alright, so today we're going to look at wrapping up section 2.1, briefly talk about some notation for derivatives that you might have seen already, and then some reasons why a function would not be differentiable. Okay, so if we look at notation for derivatives, you can represent it by saying f prime of x. You might also see y prime, you might say see dy over dx, you might see the derivative, same thing as saying the derivative with respect to x of our function f of x. Okay, so these are all ways that you can see how functions are represented as a derivative. All right, there's some reasons why a function may not be differentiable. And you might have seen this already when we were graphing derivatives yesterday. But the first one is that f of x has a discontinuity at x equals 0, x equals c, so some point. Okay, so there's going to be, you're not going to be able to draw any tangent line. So no tangent line. And remember, discontinuities could be like a jump, a hole in the graph, vertical tangent. Okay, so there is our discontinuity. Second reason, f of x has a vertical tangent line at x equals c. Okay, so if you think about that graph, oftentimes it's like x raised to the 2/5 or something like that, where as we get closer to c, it kind of looks like it'd be a vertical tangent line. So slope would be undefined. The third reason could be that f of x has a sharp turn at x equals c. And if you think about that graph, that's oftentimes with absolute value, where you have different slopes from the left and right. So it appears to have two tangent lines. Okay. All right, so let's look at a brief example of if you were looking to see if something would be differentiable or not. Is f of x is equal to x squared when x is less than or equal to 0, and x when x is greater than 0, differentiable at x equals 0. Okay, so what we're going to want to check is to make sure that we have the same slope from the left and right. So when x is less than or equal to 0, we want to find the derivative at 0. So we're going to use the limit definition. We're going to say the limit as h approaches 0 of f of x plus h minus f of x all over h plug it into the first part of the function. So x plus h squared minus x squared all over h. Use FOIL. Cross off the x's, and then we're able to factor out an h. So our derivative is 2x, but we want it to be at 0. So it looks like it would be 0 for our slope. Okay. When x is greater than 0, I'm going to find f prime of 0. So it'll be the limit as h approaches 0 of f of x plus h minus f of x all over h. So we would have x plus h minus x all over h. The x's get crossed out, the h's get crossed out, we're just going to be left with 1. You'll notice that these two slopes do not match. Okay, so therefore, the one-sided limits are not equal. So f of x is not differentiable at x equals 0. Okay. Note that if something is continuous or not continuous, right away it's not going to be differentiable back up in this list. If something is differentiable, then you can immediately assume that it is going to be continuous as well. All right, so let me know if you have any questions, and that's it for today.